Okay, so today is the 19th. That's why we have a quiz. Okay, so last class we learned about functions as a relationship between numbers in which for every input value there is one output value. The set of all the input values is called the domain. I got that. Nope. Okay, domain. And the set of all the output values is called the range. So functions can be represented as by tables of values or by mapping diagrams, right? And I've made a point to give you a table of values, which the headers were inputs and outputs, but on the mapping diagram was actually domains and range. And the reason is because they're the same thing. Right? The inputs are the domain, the outputs are the range. And this is the same relationship. Okay. Notice that if you have to draw a mapping diagram, that it's an arrow, right? It maps from one in this direction, right? It's not like I can say, what is the range is 5, then what is the domain? It always goes in the other direction, right? That's why this is the independent variable. That's the one you start with, and it goes in that direction. Kind of like we said when we were talking about just the definition of a function, right? A function functions. It works. If you want to know how much you make based on how many hours that you've worked, you got to give it the input, how many hours did you work? And then the output is dependent on how many hours you worked. So independent, dependent. Don't eat in here, right? Put away, or else your classwork is a 0. Okay. When there's a mathematical pattern that describes the relationship between the inputs and outputs, then we can write a function rule. Right? But before we can do that, before we can say, what's going on between inputs and outputs, we need variables. I mean, now's when we actually have to introduce variables for ourselves to represent the inputs and the outputs. And what are I think you guys have done enough of this already. What are the letters we usually use for inputs and outputs? It's usually X's and Y's. It doesn't have to be. Doesn't have to be, but it seems like they're using it here a lot too. So here I got my table of inputs and outputs, but I also have included the X and the Y, right? X represents the inputs and Y represents the outputs, right? And here's all of the members of the domain and all the members of the range. And again, we're calling the X is the independent variable because you choose the inputs, and Y is the dependent variable. So when I said there's going to be some kind of mathematical relationship between X's and Y's, it means, you probably see a pattern just if you go across the X's, right? It looks like it keeps going up by 1. And the same thing for the Y's. That's not the pattern we're looking for. What's going on between the X's and the Y's, right? How is it that this 0 becomes a 3, and this 1 becomes a 4, and this 2 becomes a 5? What must you be doing to the inputs? It looks like you're adding 3, right? So in terms of a function rule, we would write it like this. Y, which is the output, equals X, the input, plus 3. Now, if you write a function rule, then something good to do is to just make sure that it works. I mean, plug in the numbers that you've got and make sure in every case it looks like it's 3 more. You can sometimes come up with something that works maybe for the first number or 2, but maybe it doesn't work for all the numbers. You've got to think a little harder. So that's a function rule. Again, and this is, now what if I say I'm going to have a new input, my input is going to be 5. What is the output going to be? It's going to be 8, right? So 5 is that's the independent variable. So I'm going to plug that in this expression, which is on the right, And then I'm going to, then y, whatever y is, depends on what I plug in there. 5 plus 3 is 8. So this is the independent because it's in the middle of this expression on the right. Y is the dependent. Okay, let's write a function rule for this pattern. Again, since y is the output, it's going to be solved for y. What's going to be the expression on the right that describes what's going on between the inputs and outputs? Can you see a pattern? What are we doing to the inputs to get the outputs? Hi. Y equals x plus 2. Correct. Okay, here's your U try. What is the function rule? For the pattern. Who's got the pattern? Who won? Can you be different? Lily. Okay, so remember, it's an equation now. Y equals, you said x times 8, nothing wrong with that, but normally we would probably write it like y equals 8x. Usually if there's a variable expression, it's got a variable and it's got a number with it, the number goes in front, and then you call it the coefficient. Does that look like that describes everything going on there? 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32. So it looks good. That's a function rule. Okay. What if I plug in x equals 5? What's the output? 40, right? So the value of the output depended on the value of the input. Okay. So given a function rule and a domain, then we can find the range. For example, if we have a function rule which is y equals 2 times x, and we say that the domain is this set of 5 points, then how can we find the range? How would I find the value of y that goes with x equals 0? Hunter? Yeah, you would plug in all the domains one at a time into the x value, calculate, right? Y equals 2 times 0, which is 0. Y equals 2 times 2, which is 4. Y equals 2 times 5, which is 10. Y equals 2 times 7, 14. And y equals 2 times 8, which is 16. So the range, again, if I write it properly, is the curly brackets 0, 4, 10, 14, 16. Right? So if you're given a domain, you calculate the range using the function rule. Probably the next one is for you. So you try to find the function rule find the range if you know the function rule and that domain. Okay, what was the range? Anybody? What's the first member? 5, 7, 10, 13, 24. right? So for each one of these here, you just, for the first one, y equals 10 minus 5. Just plug in those values one at a time, right? And that's the range. And if you're really being good about it, you put them in those curly set brackets, then you're perfect. All right, word problem. You are buying concert tickets that cost $15 each. You can buy up to 6 tickets. Write a function rule that describes the amount you spend as a function of the number of tickets you buy. Okay, so how much is it going to cost if you buy 1 ticket? How much is it going to cost if you buy 2 tickets? 3 tickets? So what's the general function rule going to be then? Y equals plus 15? Okay, if it's x plus 15, then let's see. If I buy 1 ticket, 1 plus 15 is 16. What should it be? It's actually x times 15, right? So that's the reason. If you write down your function rule, then make sure that it works. Plug in a few numbers, make sure it makes sense. So it's actually 15 times x. That's our function rule. Okay, what's the domain? If you could buy up to 6 tickets, then what do you think would be your domain? Felicity? 1, 2, 3, 4, 5, 6? You know, I could make an argument that you could put 0 in there, but they did say you are going to buy tickets. So I guess that presumes you're going to buy 1. So let's say it's just 1, 2, 3, 4, 5, 6. Could it be 1.5? Yeah, you got to buy whole tickets, right? In the context of the problem, it wouldn't make sense to say that. Okay, then how am I going to find the range? Multiply what? What are we multiplying again? Jackie? What are we going to multiply to find the range? Yeah, 15 times each member of the domain, right? That's the way it works. So you're going to plug these in there, right? So what are those values going to be? The range is, the first one would be 15. It said I think we already said 3 of them. Now, if you don't know it, you plug it in the calculator, right? What's 15 times 4? 5. 75. 6. 90. So that's all the possibilities of how much you're going to have to spend. So bring the money or bring a credit card. And that's it. So the homework is going to be on page 38, same page, 14 to 21 and number 25, one-word problems. You know, write these down so that when you finish your quiz, you can work on homework. We have plenty of time. This quiz won't take long.